The joys of regulated space. Who's worked in a regulated industry? How long did you last?
Still there.
Round of applause for everyone who's still there. So, yeah, I've worked at a bunch of regulated industries. I did a big stint in finance. I suppose actually I should do that slide because it tells some stuff. Currently, I'm at a company called OptumUK. You won't know who it is because it's an American brand who bought EMIS Health, who might know. Failing that, you'll know TTP because that's your god-awful thing you have to log in to get to your GPs. So that's me, LinkedIn code, usual stuff. Various exciting things that I've done in previous lives. Right, starting point. So when you're dealing with regulated industries, and you want to do something cool, exciting, sexy, and new, what's the usual reply? Do we have any bets?
No.
At least it's a starting point. Yes, it's a very steep cliff to climb, but you've got someone to start having a dialogue. So what you have to basically understand is, why are they saying no? Yes, there's lots of dark, stormy clouds. A lot of these industries have been around a long time, and there's been a lot of change, a lot of things. A lot of these regulations are written in blood. So you have to try and take that inertia that the organization has built up to protect itself and try and see how can you shape it. With healthcare, the big ones are, the big ones are clinical risk. Anything with healthcare, this is usually gets mentioned at least first couple of minutes of any meeting. Because when you're dealing in healthcare, is that you're dealing with people's lives. Even if it's, silly parts like cosmetic, there's drugs, people got allergies. So there's such a large area where things can go wrong. And this is why the industry has built up this huge layer of protection around itself to try and mitigate these risks. Because they basically need these systems to be correct. If you're prescribing, say, drugs or whatever, you need to make sure they don't clash with anything, cause any weird and wonderful side effects. There's a big push for what generics are there. So you need to make sure that the answer it gives whoever's prescribing these drugs at that point in time is correct. Otherwise, some bad things can happen. There's also with security, is quite often you've got security, you've got GDPR. With healthcare, you're dealing with everything. You've got the full works, apart from political stuff. But pretty much whenever you do your GDPR training about all the bits of information that you've got to try and get rid of, never take, because there's so many rules and regs around it. Well, the healthcare, you've got everything apart from politics. So you've got to try and keep track of your data. And since you're sat on this huge gold mine of data, this is why security are really funny about it. So you've got to understand, okay, if I'm going to bring something in, how do I make sure that it doesn't impact, say, the clinical safety, it doesn't impact what's going on so they can't do the tracing, the auditing? How do I keep the security to make sure that it's all ring fenced? Make sure that it's only accessing data that it needs to. So we basically got to look at their fears, their concerns, and say, okay, how do we break this problem down, get them to come on a journey, is what the buzzword the consultants love to say. To get them to basically say, okay, we address all your fears, we acknowledge all your fears, and this is how we can essentially shape AI, which is a really powerful tool to fit, the regulations that you've built, the processes and procedures that you've built. So there's going to be a lot of shaping. So the first argument is, okay, we have AI ops. What does the Legion of Doom give us? Apart from, a nice bank of apparently even cheaper bodies. Machines are really good at crunching data. So they're very good at spotting trends. So you can throw all your data. So So from an operations point of view, you can throw at most of the estate, start chunking through all the data to say, okay, what looks weird, what looks like is an issue. With the, well, spread of like various technologies, say like microservice backends, micro front ends, which are also really fun. You've got all these different disparate technologies, all need to work together in order for it to give the desired result. And since you're healthcare, it has to be right all the time. So bots are really good at trawling through this, can take a lot of the weight off, allow your teams to focus on other more high value things like, I should really think of something for that. But yeah, it's all the value adds to dealing with the customers, making sure we do the improvements, open up to the customers. Another thing, especially with modern AI, especially large language models, it's basically just stats. The way that it works is essentially just guesswork. It's really educated guesses, but as you plug all your data in, the LLMs, they basically say, okay, I'm at this point, what's the probability of that I'm going to hit something close to it in its vector graph? So it allows you to basically plug together a load of scenarios via various guesswork. Yeah, you could do this all with if statements. The problem is with if statements is that you're baking in a lot of assumptions when you write this script. And when you've written the script, it's that point in time. Yes, that's really nice for, say, change control and for, say, like the clinical governance side of things, because you can say, this is my list of if statements, this is how it works, I've tested it, every possible iteration to it. So that's why in traditional regulated, especially with healthcare, is they've stuck to things like this, because it's nice, predictable, it's easy to do the sign off, you can test it. The problem is that when you end up with these massive systems, especially interlinked systems with things like microservice mesh, it's not just a monolith where you know all kind of your inputs, your outputs. It's a sea of possibilities. So either you have to have an if statement that covers everything, or you're going to have some flex in there. The other thing is that it's a relatively simple task of disk being full. I'm kind of horrified how often this keeps happening with our estate, but that's a different matter. You've got a whole bunch of different solutions there, but each one of those blocks, there's more detail that you could go into, is that especially down the bottom where it says things like archiving old data. What is old data? You need to have the context around what to do with these different systems. So either that you're going to have this workflow for every single type of system you've got with every single type of data, or you're going to have to expand these blocks to cover every single eventuality. So you end up with this massive workflow that you've got to build, maintain, and go forward. Everyone's heard all the horror stories of AI. I assume you've seen all the social media posts where it's done something terribly stupid. So what we have to do is to try and take this glorious little thing and shove it into its happy little sandpit there, where it can play away to its heart's content. So you've essentially got to start opening up access to parts of your estate. You don't want to give it access to everything, because that's when interesting things happen. Usually not for the best, unless you want really good engagement on LinkedIn and various social media. So you can use things like MCP to plug into your third-party tools. If the vendor's done their job correctly, which they're slowly doing, is that you're going to have various RBAC on the back of it. So you can very much use that to gate what the AI can see, what it can't see, what it can query. For our space, there was a big concern about leaking of data, but a lot of that seems to have got resolved, or at least they've signed a piece of paper saying it's been resolved. So we can then use it to start querying, but we can't just let essentially an AI through an MCP start doing modifications to the system, because we need to understand what it's doing. So yeah, we use Dynatrace for our SINs. It's MCP, it's all right, but it allows our agents to basically form queries, which is the important part of grabbing context about what's going on in your system. So things like your Dynatrace MCP, your AWS MCP, you can use that to query to see what's going on. This is an important part about giving that context to the AI. Yeah, I know it's a bit traditional, but when you're trying to use your sandboxes, you're trying to sort of go to your governance and say, we kind of have guardrails around what AI can do. Well, we have a whole bunch of runbooks that have come out from the legacy system. This is stuff that's been tried, tested, it's been approved. So what we can do is keep using those runbooks, because that gives us a fixed known point of interacting with the systems, and then use AI as that bit in between the detection and resolution to basically start picking which runbooks should be used. I'm going to say, guess which contract we've signed. So using tools, again, ServiceNow is what we signed up to, so there's going to be a lot of it. Yeah, there are other vendors. You can essentially plug into these machine learning tools all your knowledge, all your different runbooks, to basically start addressing points one, because you need to give it as much context as you can to understand what's going on. That then plugs into the rest of it, things like the reasoning. That part is going to be important because you want to know roughly what the reasoning is, especially if you want audit trails and building plans. So it's all about getting the correct data in, your knowledge base, to use your runbooks to build your knowledge base up, use all your existing information that your operational teams have got, shove it in, and then see what AI comes out with. The way that ServiceNow does essentially its AI is that essentially every task is kind of an agent. So you define an agent with inputs, outputs, what it's supposed to do. So in the case of, well, the example before is like disk is full. So you could have an agent saying, okay, what is this agent going to do? I'm going to tell it the disk is full. It's going to go off, work out what needs to be cleaned up. How does it work out what needs to be cleaned up? It can get that from the knowledge bases that you've plugged into it as all the different suggestions. Yes, I could use a script. There's an option to use scripts to say plug in a massive list of ifs to say, you know, if it's this system, delete these folders. If it's this system, do this. Or you can use, you know, the AI models to say, okay, the probability, looking at all the inputs, you know, looking at the alert that's been fired, it says it's this box, it's this type of service, it's running these things, it can detect, pull that in, look at your knowledge base and say, probability, it's probably this folder that needs to be cleaned out. So you can build that up through text, which again, a lot of this text can come out of your traditional runbooks. So again, you can use that with your traditional teams to start spelling out like what do we want to happen, how do we want it to happen. You can also put in guardrails and all those bits. Problem is it's an AI bot, so treated like a black box. Just because you told it to do things doesn't necessarily mean it's going to do it. There's still a bit of hallucination in there. The interesting part, especially with the ServiceNow, is the scripting part, because you can use that. Like if there isn't an integration already out of the box with ServiceNow, which there should be, the amount of money it costs, you can use scripts to basically talk to your particular systems. Another interesting point is you can then plug it into your authentication methods and have it talk directly to APIs, but you know, in a space you can't guarantee and provide all the gating around what it can do. So I'd only use sort of scripting to basically grab information from your systems to give it more context about what's going on. So yeah, it's just examples from the documentation. This is basically the magic, what you spend all the money on with ServiceNow, is that what it does is it can essentially build workflows by itself. So you can have a triggering event, it will then build out, click together all these different agents, tasks, whatever, and essentially produce this workflow and give you a bit of rationale, or the decision log. The decision log is what the security and auditing guys quite liked. So they can basically roughly say, okay, how did we end up with this particular resolution about what's going on? Why did it trigger the particular steps that it did? For us, we're very much wanting to put it into a sandbox and make sure that it doesn't get any ideas. So it very much is, we allow the AI to read what's out in the estate, it can see what's going on, get all the full context, but if it wants to do something, it's very much as pre-canned, and the route that we've gone is we've gone Event Bridge to essentially fire down messages. We've been slowly building out runbooks which trigger SSM docs, so we have all those already, so we can repurpose a whole bunch of them, but what it gives us is a set API that we have a message that gets emitted, sent down the event bus to the correct doc. We can define what our inputs are, and we can also control what those processes do. There's things like if you're doing like rolling updates, you can bake all the roll forward, roll back control to make sure that it doesn't do something stupid like turn off the only running server or any of those bits. You can control that very much statically, prove that these actions, this is what it does, this is what it doesn't do. That gives the safety net to the auditing and the compliance, so they can see, okay, these are the particular set tasks it can do. How we get strung together, the order we put them through, that's down to the AI to try and work out what part of the system needs to be scaled up, scaled down, bounced, clean up disks and all those sort of bits. We can also use that to hook into our systems to run like BAU tasks and all those sort of bits. So this is very much built on a lot of the run deck type activities that we have already, and we're just building on top of it by having the AI in there. We can do quicker responses to incidents. So they seem relatively happy with that. They're sort of wrapping it around using these static SSM docs. So it's limiting essentially what AI can do. You don't want to limit AI what it can see, how it makes its decisions, because that's where a lot of the power is. But until they really sort out hallucination, you can't really trust it enough for, say, like clinical risk to start doing these tasks where you don't know 100% what the task is going to do. Okay, you don't know how many times it's going to reboot the box, but you know it's going to reboot the box like the set process that you've defined. So then you can basically go back and look at your guardrails around it. It's also getting it to suggest new runbooks, getting more of the power. So it's very much feed all your data, see what it thinks, have a set list of options it can run, and then see what novel approaches it provides. So again, what do we need to do? Feedback is kind of the key to these AI systems, and is also one of my biggest arguments I have with the software engineering teams. Is pretty much on most instances I get dragged into, my first question is, okay, what does good look like? How do I know your system is working properly? What does bad look like? How do I know that your system isn't working properly? I'm amazed at the number of teams who can't tell you an answer to that. If a human engineer with 15 plus years can't tell that, can't work it out by looking at all the metrics and all those bits, what chance essentially does an AI bot have? So you need to define these metrics, because really all these AI bots do is chase a metric. They have a success criteria. They're going to work out a way to try and hit whatever that number is. So you're going to make sure that you defined your service, what's good, what's bad, to make sure that it starts heading towards what's good instead of what's bad. Like I said, is that you can reboot a box because something's locked up. It keeps locking up, it keeps rebooting it. You don't want to keep it doing that because you're just essentially doing a manual, or you're paying a lot of money for a crash loop. So you've got to put guardrails in there to say, hey, you've rebooted this X number of times, that's a bit much. Or that, you've rebooted this X number of times, maybe this needs to be escalated up to somebody, to a human to see what's going on. So it's making sure that you have those guardrails to say, hey, you've gone a bit too far, to try and sort of bound it, and to making sure that what it's trying to target with all this information is actually what your system looks like good, and trying to get out as many use cases as you possibly can. The important part is monitoring, because you need to have the ability to see what's going on with the app. The thing for regulated space is observability of actions. If you're working with any large system, is that you're going to have the joys of CAB, or at very least some form of change control. So if you've got these AI basically triggering all these different tasks, altering the state of your estate, you probably want a record of it. The nice thing about it is that we've got Event Bridge, so we have a list of all the events that are going through, so we can look at what's been changed. But the important part is, when it was going back to the workflow, is that why did it decide to do those particular set of things? Why did it decide to reboot this particular server that number of times, and then shunt, do a queue reset, or all those sort of bits? Why did it decide to pick those particular options? Mainly because for auditing and regulators, if anything weird and terrible happens, but also is that it's for you to improve, to take that information and say, okay, that many reboots is too many for this particular system. We need to increase the timeouts, how long the agent waits, and all those sort of bits. And this is very much what you need to have a discussion with the clinical safety side of things, is, are these activities, have you got enough guardrails in your, for our case, it's the SSM docs to say, when it performs this action, it does it in a safe way that maintains the system, that keeps it going. Like, if we're having lots of issues with a particular application server, pop it out the pool so it doesn't affect everyone else, sort itself out, put it back in. Do we have all that wrapped in our scripts so they don't get forgotten about? Because AI tends to sometimes forget, even if you tell it. And the usual thing of plugging all your changes and those bits into Seam. Again, if you've got some kind of event stream of all the different actions, case for us, we've picked Event Bridge, feeds it all in there, so then security can check to see what's going on and see if anything odd is happening. But the hope, what we're planning to expand the schema, is it should be quite tight. So what we're hoping, there won't be much scope for anything too particularly weird and wonderful to happen, to keep the security guys happy. And it's looking at the tasks. Is once you understand the particular model that you're using, again, this is all going to be very ServiceNow because that's the one we've been using, but you could build this stuff out of AWS's, what's it called? I keep being sent on training for it. I can never remember its name. Whatever the AI tool is, you can build all this stuff yourself with your own models. ServiceNow is just providing us with a very opinionated set way of doing things and a bit of professional consultancy. It's building your guardrails, so it's understanding how the model works, reacts, making sure you cover it with enough of your guardrails. You're breaking your tasks down to a tight set of inputs and outputs, so the AI can basically plug all these together when it builds out a workflow. The more, it's more like it's like caching. You want your cache to be the largest, smallest usable component. It's the same with this. You want these components to be as reusable as possible to save you having to do a lot of the work. And it's reviewing like why has it done these things, the tuning and those bits. This is one of the areas that we need to spend a lot more time with, because we've essentially come out of a POC for this. I'm gonna say, how much time have I got?
You've got about 5 minutes.
Yeah, big problem we got is current gap is hallucinations. Even with the POC, we were still shaking stuff out. So yeah, the big thing with AI is it's only as good as the data you give it. So you need to give it as much clean data context about what's going on to try and help you as much as you can. But that's kind of the same with any incident. If your first line, second line support have just been flooded with a load of noise, they're going to struggle to fix it. So it's no real difference. AI should help you cut through the noise quicker, but it's still extra work and it still has to work out what's actually relevant. Questions with the last 4 minutes.